Before we look at this question, let's review a property of fractions. If I have 1 over x plus y over x, can I add these fractions? Sure I can, right? That's one of our fundamental fraction rules, that if you have two fractions with the same denominator, well, you can add the numerators. 1x plus y xths is the same as 1 plus y xths. But what I want to look at here is I guess this process in reverse. We could have started with this and then separated this sum in the numerator and this single denominator, and then separated it into two fractions. The first term in the numerator over the denominator plus the second term in the numerator over the denominator. And that can be kind of helpful. Let's say I have z plus 4w over 4w. Well, if I wanted to, I could say, well, I'll just turn this into two fractions. I'll do my adding fractions with the same denominator in reverse. This is the same as the first term in the numerator over the denominator, plus the second term in the numerator over the denominator. And in this case, it's kind of helpful because this whole second term reduces down to 1. This original expression could be rewritten as z over 4w plus 1. So that's kind of useful to keep in mind. And if we think about why that happened, well, it happened because our denominator, the thing in the denominator, was one of the terms in the numerator. So when we separated it into two fractions, one of those fractions reduced down to 1. So a useful tiny little algebra fraction trick that can be helpful. Let's keep it in mind as we look at the question. What is the value of 2t plus t minus x over t minus x? And that, of course, is a question. This is nothing we know. We're wondering what the value of this kind of ugly expression is. And because it's an ugly expression, my first impulse is to try to make it nicer. Before I look at the statements, I want to see, is there any way we can rewrite this question? And they've actually written the numerator in a bit of an odd way. They have 2t plus t, but they could have just written 3t, right? But they chose to write 2t plus t minus x over t minus x. And my guess is that the reason they did that was to, well, I guess make the shortcut method, or the shortcut option, a little bit more apparent. Because written this way, we see that this expression, written this way, if we're keeping our eye open for shortcuts, we see that this expression is actually very similar to the expression we just had. Here, the denominator showed up in the numerator, and here, our denominator t minus x shows up in the numerator. There's our t minus x. And when that's the case, it can be especially helpful to split a single fraction into two, as we did here, because then one of them is going to reduce to 1. So let's split this guy into 2. Now our question is, what is the value of, well, splitting this into 2, we get first term in the numerator over the denominator, t minus x, plus second term in the numerator over the denominator, t minus x over t minus x. And that's what we're looking for. Sure enough, this guy is going to reduce down to 1. So, our question, what is the value of this thing? And keep that question mark there. Always want to remember that this is a question, not something that we know. And we can go one step further, reducing this down to 1. Now our question is, what is the value of 2t over t minus x plus 1? Question mark. And I would say that this is a little bit less intimidating than this original question. Now to answer this, to get a value for this, what are we going to need? Well, to get a value for this, if we had values for t and x, well, that would do it. So that would be one way to get sufficiency. Or if we just had a value for this expression, we'd be able to find the value of the whole thing, right? So if we get enough information just for this part, we'll be able to answer the question. All right, on to the statements, on to the facts. Fact number 1, Fact number 1 tells us that 2t over t minus x equals 3. Is this going to allow us to answer or to get a value for this whole expression? Well, it's not enough to get the value of the individual variables, right? We've got one equation with two variables, so I'm not going to know what t is. I'm not going to know what x is. But we might notice that this expression is this expression. So actually statement number 1 tells us that this whole thing is 3. So our question is just, what is the value of 3 plus 1? And that is something that we can answer with a value. So statement number 1 is sufficient. Oops. Statement number 1 is sufficient. And that gets rid of answer choice B, answer choice C, and answer choice E. On to statement number 2. And we have to forget about this information. Statement number 2 on its own. T minus x equals 5. Let's see. Does this help us with our expression? Well, we know the denominator now. We know that t minus x is 5. So 5 on the bottom. Do we know the numerator? I guess to know the numerator, we're going to need to know t. Let's see. If t minus x is 5, well, no, we don't know what t is. There's all kinds of things that would subtract together to get 5. This could be 6 minus 1 equals 5. Or it could be 100 minus 95 equals 5. And if t is 6, that's going to lead to one value up here. If t is 100, that'll lead to a very different value up here. So, statement number 2, well, that's not enough to know the value of this whole thing. Statement number 2 is insufficient. So D is not our answer, and we click